Okay, perfect. So thank you, Henrik, for the introduction, and thanks to everyone for be part of this initiative. It's a real pleasure for me to be part of this 24 hours virtual session. So to quickly introduce myself, as I say, Bruno Da Silva. I'm a performance consultant at Linovia. And today I want to give you some insights on continuous performance and some tips to innovate your performance testing process. Even though I have no demo today, I'll make sure that in the following articles to go in depth in the technical parts to make sure you understand what has been done and how you can be inspired by it to do something similar in new contexts, in new companies. So let's start by reviewing basics. So performance 101. Okay, so let's start this session by reviewing three basics in performance drivers. Personally, I identified these three axes. That's how I view them, and it's easy to picture it this way. So the first one is about the application. So it's its functionalities, the design patterns used, the frameworks implemented, backend usage, etc. So basically, it's how the application is designed and developed. So this is a big part of the performance challenge. The second one is about resources. This goes because of the application, because it relies on resources to provide a good working of the application. So you might have low performance from virtualization, for example, or clustering, network capacity, or maybe you have components overused by many applications. And finally, the third one is about load. I see it as being the usage of the application and the resources. So it depends on the use cases, the user profiles, load peaks, etc. So we're going to get back to that afterwards. Moreover, in this context, you see that if the application is new, you have very little information on the load that your application will be exposed to. So it's very difficult to anticipate this part. So let's see in each way continuous performance is relevant. Okay, so I identified three big performance testing categories. The first one is the continuous performance testing. That's the one I will be addressing today in regard to a shift left approach. And which main goal to me is to control the robustness of the code. The aim of continuous performance category is to check for no regression mostly, and must be automated as much as possible. So among this type of testing, we will find, for instance, unit testing and compounding testing. Nevertheless, this continuous performance approach lays ground for the traditional performance testing category, which we often do to check for architecture stability. So for instance, that's the soak testing or stress testing approach that we do once the application has several functionality built and is quite stable. And finally, the last category is the advanced performance testing. That's how I will call it. Because even if it's rarely done, it's a good opportunity to deep dive and test for real world experiences, such as user experience you can measure, or testing for resiliency of your system upon critical failures. So for example, the failover testing. So don't forget that the way you test performance depends on context. For instance, if you are facing a high risk regarding to your business, you might want to perform all of the later steps to deep dive and to secure production. Maybe you want to go even further and to ensure resiliency of your system, and maybe go to a blue-green deployment approach, or even chaos engineering to ensure both performance and resiliency. And also, again, this depends as well on whether the app is new or existing, because if the app is already running, you can automate your pipeline in order to measure changes and check for no regression. If this is not the case and you have a new application, you'll be focused on meeting performance requirements because this is a priority. But however, let's try to capitalize in order to build your continuous performance strategy for future iterations. Otherwise, it will be too much work to do at once. Okay, so we reminded ourselves of the key performance drivers, so application, resources, and load, as well as performance testing categories. Now let's review continuous performance challenges. So firstly, there are many benefits. So the following list is what's the most relevant to me, but you can think of other advantages, and I'll be happy to discuss it in the QA session. So continuous performance might be costly, but if you think about the impact of low performance on your service and therefore on your image, it's better to detect the effect in an early stage like design and development than in production. For sure, you are mitigating a risk by considering performance as a requirement and not as a bonus. This state of mind helps you a lot in challenging your architecture and adapting it to your context. So I think it's really valuable. This strategy is efficient also to improve code quality and stability, because when we are in a continuous delivery process, we tend to go very fast and forget about quality. But I think it's very important to test early in order to improve code. Not only you can focus on unit or component performance testing for key functionalities, but your automation is your best ally when you'll be checking for regression detection, which are likely to happen if the application evolves. Another benefit that should not be overlooked is monitoring. As we know, as performance engineers, monitoring is a key both for performance testing and for production incident analysis. So tuning monitoring before production is mandatory because you should check that you have all necessary metrics, alerts, and reports available. If you are facing an incident in production and your monitoring is incomplete because you haven't properly tested it, resolving issues will get very difficult. That's why one of my most important recommendations is to build performance together. Performance is everyone's job. And I think we should involve everyone, every developer, architect, experts in the domain, in order to make this strategy to work. Otherwise, I think it's not possible. And finally, one of the big benefits of this approach is by building your scripts and environment and monitoring progressively, it makes it easier for future performance testing, as most of the effort has already been made and anticipated. The biggest challenge here is not really on the tools, as we have plenty to address performance as early as possible, but more about the process. We're going to develop a model is really challenging for companies still following a waterfall model. But even if it takes time to change how we address performance today, I'm convinced automation of low added value tasks are essential in order to tackle high value performance concerns. That's why it changes the way we work as performance engineers. So what about the prerequisites to meet before starting? Defining the performance requirements is important if you want to be able to measure it. Requirements are often expressed according to time in order to measure capacity of a system. An interesting quote by Michael Nigard in Release It on capacity of a system is the maximum sustainable load throughput for a given workload while maintaining acceptable response time. That's a very good definition, and you should take it into account before writing your first line of code. What is the purpose, or what do I expect about the application? The next thing, obviously, is to be able to test your application. You might encounter a software you cannot test because of the complexity or the protocols involved. It's not often the case with web applications, but you might need to adapt your strategy if efforts required is too much compared to the value added, or maybe do longer sprints to adapt to your context. Also, production-like environments. Make sure the way you test your application is as close as possible or like your production environment. If it's too specific, it will be difficult to conclude on how to build your production environment. Not only your results might be biased, but you could include manual error when configuring, installing this kind of environment, and so in production. Obviously, the delivery pipeline, you need an operational delivery pipeline, continuous delivery integration server. I will get back to it later on, but it's essential in order to address the automation part, because it will be an important work for your team if it had to be done manually. And lastly, as I was speaking before, is about building performance together. And I think it's really important to understand, because when it's about performance, everyone is impacted, not only the performance engineers. For example, it will be the architects on how the application is designed. Later on, the developers by the quality coding and unit performance testing on the key components, functionalities. Performance engineers on load and dataset definition. If you have a bad load design or dataset definitions, you won't have reliable results to control. And finally, the operation team on the available resources for your project. Finally, the monitoring is key, both for the application, server, and the usage, to have a baseline on what you are doing, and to have good conclusions for comparing your test to previous ones. Okay, so before going further, let's tackle the automation limits, because we still need manual action in order for the process to work. And I like to point it out because it requires some time. For example, when you do performance testing, you need to maintain your project and your scripts. Even if you have correlation rules, you have some configuration to do, like client side, for example, defining your data sets, think time, pacing, etc. Same goes more or less for monitoring. You want to make sure you have all the metrics you need, and it may require a certain effort in configuration, both for your alerts and reporting. And finally, your continuous integration and delivery pipeline, because even if automation saves a lot of time to the team, it takes some time to initiate it and to maintain it when you have new versions and new type of tests maybe you want to do, or new type other deployments, etc. So there's still some work to do on this part. Okay, so now that we reviewed the continuous performance key concepts, let's be more concrete on how you could integrate it. So these categories and tools are from my experience. There are many tools you could use to do the job and maybe other goals you like to achieve. But these ones have proven to me on different projects they are really powerful and they do the job I expect. So that's why I give you at least one example. But I'm sure you'll find other tools that do the same things in each category. So for performance testing, you should pick a tool for both load and stress testing, but you should make sure you can capitalize on your load test scripting so you save yourself time on the next iteration. This part is really important because if you spend too much time in each iteration maintaining your scripts, it will be really difficult for the performance engineering team. So that's a huge time saver. Same for the monitoring. You will want an in-depth full stack analysis of your application and the ability to compare your results between production and test, because that's how you will see potential regressions and what is limiting your application. Of course, this strategy should be conducted from the earliest stage of the application development. So you should add it into your continuous integration process so you can check for performance stability and automation. The deployment aspect is essential to me because when using containers, you gain consistency and easier environment deployment for your application. And to me, it's important as well for creating injectors on your demand to reach the load you want. Finally, about data generation, as some have spoken about it before, you can use a tool or you can do it manually by developing it on each release or have data automation generation. But it's important to be careful on this aspect because that's how you will perform a realistic test. And even if it requires a specific development, I think it's important when you go to this type of continuous performance process. Otherwise, with dummy data, you will miss many things because of cache, because of data not being representative of reality. And of course, if you want to get more in detail on the tools, here are some examples from my experience, for example, on a Java application. So you'll need a source code repository, perform some unit testings, Maven, SonarQube for dependency build, SonarQube for code quality analysis, a binary repository, automation in your deployment and configuration by script, and browser simulation that you, for example, you can use for functional test or to maintain your load test scripts, which is a huge time saver. And you can go even further with the notification to your performance team on each iteration, and the log analysis that you should not forget because you will have a lot of information. I use the Elasticstack, but if you are using a monitoring tool that integrates the retrieving of logs and analysis, you can do this as well. Okay, so this is just an overview of the Jenkins and the OpenShift integration. The idea is to use an ephemeral Jenkins server capable of executing Jenkins pipelines using OpenShift pods that act as Jenkins slaves. With the help of OpenShift Jenkins plugin to dynamically provision slave instance, the Jenkins master communicates with OpenShift API to manage the lifecycle of slave instance. In our example, we'll be using a Maven node to build and package a WAR, and then building the WAR using a Docker strategy OpenShift build. So I propose you this simplified architecture. I hope it helps you understand how the pipeline works. There are several examples of this type of integration, but the main idea is to trigger the pipeline with a code commit, for instance. This way, Jenkins will retrieve the source code and build the application with its dependency and run unit tests. After that, we can deploy the application to the test environment. Even the environment can be built on the fly, so as I highlighted with OpenShift. And once everything is ready, you can trigger the load test with new load, for instance. Your environment being monitored, you can retrieve the metrics with Dynatrace and integrate both tool in order to analyze how your application is performing. In the end, the test report is available for analysis so that you can work on potential regressions. You'll notice how I highlighted specifically the use of OpenShift for the test environment and Dynatrace and Neoload. This is really powerful in order to deploy easily your environment and even create as many injectors you need for stressing the application. So in practice, here's what a pipeline looks like in Jenkins with Blue Ocean. Most of these steps are known, like checking out code, then performing code analysis. Then you can proceed to unit testing before building the WAR file. Afterwards, we trigger the image build and the verification step before deploying the application. Simultaneously, we can deploy as well the load injectors, which we'll use for the load test. It makes sense to instantiate the injectors on the fly and to destroy them when the test has ended. So the use of containers for this purpose makes sense. Of course, we could have added several tests in the pipeline, like component testing, even before load testing, and also functional tests with Selenium, for example, in order to check for stability before going to the next step. Okay. So we are reaching the end of the presentation. So I would like to share with you some challenges in order to go further in the way we test performance. First one is AI for result analysis, as it will be a huge time saver to stating easily if a test has passed or failed. Of course, we have several metrics we usually check, like response time, error rate, resources, but it can be hard to define meaningful SLAs as features may evolve across time. So it may be challenging to detect real regression. Another interesting aspect will be to go from protocol load testing to a browser load testing. I worked on a toolbox some time ago with the Grinder and Selenium, but he had several limits. I know this is challenging as it's difficult for scripting, and the injector scalability is limited when simulating browsers, but it's really interesting for measuring real user experience. Another aspect I will find interesting is to dynamically create injectors depending on the load. It will make sense in a containerized environment, and that's something I will work on in the time soon, because for now I define the number of injectors I will need, even if it's created on the fly. And finally, and I think it's a good opportunity for reflection, is how to complete this performance testing approach with a resilience testing one. We sometimes talk about testing in production and the risk it involves, but there is a way to mitigate these risks. For example, with chaos engineering, in order to test for the whole system being able to come back to a stable state after losing some pods or other key components. Okay, so this has been a pleasure sharing these ideas and methods with you. I'll make sure the incoming articles will be more in depth on the implementation part with technical tips. But in the meantime, if you have any questions, I will be happy to answer them. Thank you.
All right, thanks, Bruno. So we're just going to enable, there is a lot of PAC members connected to your session. So there is, I'm going to enable the webcams, and maybe I will be very keen to see if they have any questions regarding your session. So we have Brian, we have Wilson, we have Mark Thompson. So you can recognize the purple hair from Brian, from Mark. We have Stain. I don't know if you, Stain, have questions, but I will still enable. If you don't want to have any questions, Stain, you could disable your webcam, of course. And last we have Bruno, which is Bruno Do. Here it is. So I think I think we reached the maximum number of pre-AC members connected at the same time. So
what a success!
Yeah. So I have a few questions. First of all, I guess the image I shared by email last time on OpenShift, is this the one that you used for your demonstration, or did you build your own OpenShift containers?
We had built a bit one image before, but finally we used the image you provided us. But okay, yes, cool. It worked for the automation part. So we managed to launch several load tests, and we are working on the pipeline.
Okay. Another small, it's not a question, it's a note. You mentioned that you're going to work on the ability to spin up dynamic the load generator depending on load. So to be honest, this is something that we are working on. So okay, if you don't want to spend too much time on that, this is something that will come soon within our product by avoiding to specify the number of machines. It's going to be basically dynamically spin up the request and the required power for your test. That's just something that's going to be coming.
Okay, that will be perfect. Yeah.
All right. So before I ask any questions more from my end, I would like to know if Wilson, you have any questions to Bruno?
No, you had a great time. So this excellent presentation. I'm really looking forward to it.
Thank you.
Mark, or do you have any questions on that?
Yeah, absolutely. Thank you very much for sharing this, Bruno. It's awesome. One question I have is the stakeholders along the pipeline where you're delivering performance information, did you see a change in their behaviors, their reactions? How did you get them ready to start receiving this information?
To be honest, it depends on the different context. From my experience, there's really one client that has seen this change. Most of these change I presented. It was really complicated because we were initially in a waterfall model. So we first begin with an agile one to deliver code in a fast-paced way, several sprints, and then we started load testing some relays, and now we are going to this approach where we automated the code analysis, the load testing, and it's quite complicated. It's quite I wouldn't say a reorganization, but we have to rethink the way we work together, and it took a long time for this to happen.
Yeah, so you still have time to go to kind of see the value work in fully shifting left. You see better decisions and things happening with planning, with sprint planning, with the way they attack a story, even story construction. And so you're just getting going in some cases with that. And that's an obstacle that I see a lot with people adopting it. You might be able to move fast with the tools, but the data, the meaning of the results, that's where the value actually comes. So you may find that that's something to measure as well, is when do I see better performance decisions happening in a developer's mind when they're like, I'm going to write this differently. And if it comes more quickly. Yeah. So definitely good luck and thank you.
Thank you.
Bruno, the other
Yes.
Bruno, sorry.
Okay.
Bruno, do you have any questions for regarding Bruno's presentation?
Yes, why not? It's not really a question. It's a point of view, because on the continuous testing, one thing important is that we need to maintain the script. We need to automatically maintain the script, and sometimes it's not possible. So personally, I'm someone who doesn't believe that it's possible to maintain a script, and because there is so many reasons that an application is changing, and the functional people don't tell us the truth about what is new in the application and what's the difference in the code. And so it's complicated to maintain a script. And I personally always tell to my students that it's more quicker to recreate a new script than to maintain an existing script. But do you face this problem of maintaining a script? How can you solve this kind of problem in your application? Is it possible to maintain, or that's not crazy? That's crazy, and you are obligated to recreate a script each time on each sprint. This is my question.
Yeah, that's a very interesting question, because I've known both cases where it was a very it was more interesting to rebuild the script from scratch than to use Neoload or the tools like help to rebuild a script and to maintain it. We have several cases where it was better to do it from scratch, so it's not perfect. But for some functionalities where it has stayed more or less the same with minor changes, it works quite well. You can get going with your performance test project up to date and do your test the next week. So I will say it depends on the type of release and the evolution. It's true that if your application changes completely the way it does the functionality, yes, you have to rebuild the script yourself and not maintain it. You will lose more time, of course.
Okay. As a question that's not related to this maintenance process of scripting, and I think Bruno will talk about it later on. In fact, so that was a nice way to introduce yourself in your presentation. So my question is more about, you mentioned that you wanted to move from protocol testing to browser-based testing. Is it related to the fact that maybe a heavy framework of the market, like an AngularJS or XTJS or whatever it is, brings more complexity in scripting, and moving to those browser level technology will sort of allow you to reduce that design effort? Or is more about finding a way to report properly user experience? Why do you want to switch from protocol to load browser-based testing?
Yeah, actually, it's both. We have several requests on when we perform performance testing to ensure that the user experience is maintained, and we have these metrics. So what we can do is during the test launch some users with a Selenium script and measure for one every minute how is it performing. And it gives us an idea on how the application performs from the browser perspective. But it's true that for more challenging frameworks and how the application is coded, I think it will be simpler to do this browser testing, even if it's consuming in terms of implementing. But that's a demand that we're facing quite often. So that's why I worked some time ago on this the Grinder Selenium integration, because it answered to a need. But as I said, it was not ideal because to launch injectors to inject the same load as a protocol level, it was really difficult. Even in the cloud AWS nodes, it was quite challenging. But it might do the work in some case.
Yeah, it's all about cost. I mean, I guess you're saving in a design, but you're respending it in the load cost afterward when you do that. That's so it's a really a nice topic, by the way. And Brian Brunfield, that was a few minutes ago, as the webcam was enabled, he will talk about that that challenge about the fact that now all those new framework of the markets include so many JavaScript, so many logic back to the client. Which means that when you design scripts, sometimes it's just a nightmare, to be honest. And you sort of instead of designing step-by-step scenario, you sort of recreating the wheel to reproduce the behavior of the browser. So that type of process is very expensive. So I think, yeah, sure. I mean, that's why Load Runner came up with this True Clients. I didn't say Load Runner, maybe.
Yeah.
But
didn't realize.
Yeah. So the True Clients was, I think, for them a way to get this solution that resolve that pain, I guess. But again, many partners and customers using the True Clients are sharing the same problem about the costs of load generation. So there's always a pain. So you save it at one end, but you're it causing a consequence on the other end. So that's always a challenge. All right. Any other questions from Bruno or from Mark? No. All right. So Bruno, thanks again for your presentations. Thanks to be again a PAC member. Thank you for this awesome presentation.